In this one, I'm going to, down here, I'm going to start down here. We're going to use the inverse properties. Here are the two inverse properties. One says a raised to the log base a of x is equal to x. So an exponential function and a logarithmic function are inverses of each other. So if base a is being raised to log base a, this is an exponential and logarithmic function being applied. They're undoing each other. That's why it just equals to x. Or if you have log base a of a to the x, this also just equals to x. This is a logarithmic function being applied to an exponential function. Those are undoing each other. That just equals to x. So when we see these problems here, 66 log base t of t raised to the 2,713. This is a logarithmic function being applied to an exponential. These are inverses undoing each other. This is simply equal to 2,713. Right here, this is hard to see because of my big fat marker, but 5 raised to the log base 5 of this, 5 raised to the log base 5 of something is simply the something, 4x minus 3. Right here, log of 10 to the negative k. We understand this base to be a 10 because it's not written. It's the common logarithm. So log base 10 of 10 to the negative k is equal to negative k. All right, that's the bottom ones right there. Up here at the top, we are given this. It says given that log base a of 2 is equal to 0.301, log base a of 7 is equal to 0.845, and log base a of 11 is equal to 1.041. Find each of the following. So here's one off that I just made up. I made up these two problems so you could do the ones on your sheet. So right here, log base a of 22. I'm not given what log base a of 22 is, but I can rewrite the number 22 into some of the numbers that I see right there. I can rewrite 22 into 2 times 11. So this is equal to log base a of 2 times 11. And then I can use the product rule, which says this is equal to log base a of 2 plus log base a of 11. And I know what log base a of 2 is. It's 0.301. And I know what log base a of 11 is. It is 1.041. So I just add those two numbers together. And I don't have my calculator, so I have to do it by hand, which, let's do it by hand. 1 plus 1 is 2, 4, 3. This is equal to 1.342. All right, and then lastly, let's look at this one. Log base a of 14 over 11. What can we do with this? I don't know what log base a of 14 is. I don't know over 11. I don't know. This is like 1 point something. I have no idea what that one is. But can I use these and rewrite it into logarithms that I do know what they equal to? Yes, I can. Let's first do the quotient rule. This is equal to log base a of 14 minus log base a of 11. I know what log base a of 11 is. It's that right there. So that's taken care of. I can figure that out. But 14, I don't know what that is, but I can rewrite 14 as 2 times 7. So this is equal to log base a of 2 times 7 minus log base a of 11. So I can rewrite this using the product rule. This is log base a of 2 plus log base a of 7 minus log base a of 11. And I know what these numbers are. Log base a of 2 is 0.301. Log base a of 7 is 0.845. Log base a of 11 is 1.041, and that's just because they told me in the beginning what those were. That's the only reason I know what those are. So 0.301 plus 0.845. That's a 6, that's a 4, 8, 9, 11. That's 11. Oh, I have to line up my decimal. 1.146. So this is 1.146 minus 1.041. So 1.146 minus 1.041. 6 minus 1 is 5. 0, 1. This is 0.105. Can get the answer right there.